Ionic and net ionic equations. So first, let's start with dissociation reaction. We have potassium sulfate solid and we try to dissolve it in water. So we know that all alkali metal salts are soluble. So this salt will dissolve in water and it will dissociate completely into ions. So we'll get 2K plus AQ, right? Because of this 2 and this subscript 2 comes in front of symbol of cation. Plus polyatomic ion sulfate, and we know its charge is 2 minus. And don't forget that we don't break polyatomic ions. Polyatomic ions stay intact. Now let's look at next compound, barium sulfate. And if you look at solubility chart, you will see that barium sulfate is in the list of exceptions for sulfate. So most of sulfates are soluble but not barium sulfate, meaning in this case there is no reaction because it is insoluble. Now let's react this solution of potassium sulfate with the solution of barium nitrate, both soluble. So this is double displacement reaction, meaning that we should combine cation, first cation, right, with the second anion, and second cation with the first anion. And we never forget to put cation first. So potassium nitrate, potassium is +1, nitrate is -1. We don't need any subscript, potassium nitrate. And we know all alkali metal salts are soluble and all nitrates are soluble, so no doubts, this is soluble. Plus, second product, we should combine barium and sulfate. Barium, second column, +2. Sulfate, we already know -2, so again, we don't need any subscripts. And we already know barium sulfate is insoluble. So this is going to be solid precipitate. So it is double displacement reaction and it gives us one of the products is insoluble. So we do have reaction and now we have to balance it. So we have 2 potassium ions here, so we should put 2 here, and it balances number of nitrate ions too. So now this reaction is balanced. We can write ionic and net ionic reactions for this one. So we should break apart into ions all soluble reactants or products, and we don't break solids, liquids, and gases. In this case, we will not break barium sulfate because it is insoluble solid. So we are breaking potassium sulfate. We already know how to do that. So 2K plus SO4 2 minus. Barium nitrate is soluble, so plus barium 2 plus also AQ. Plus 2, because we have 2 nitrates, 2 NO3 minus. And it gives us 2K plus 2 NO3 minus, because coefficient 2 applies to both parts, cation and anion. And again, we are not breaking solid. So this stays intact. Now what do we see? We can cancel what we call spectator ions. We have 2 potassium ions. We can cancel. And we can cancel 2 nitrates and 2 nitrates on the right side. So what is left will give us net ionic equation. So it's going to be barium 2 plus SO4 2 minus, and it gives us barium sulfate solid. So net ionic equations always show us formation of solid, liquid or gas or combination of this. Next reaction. The same potassium sulfate, but now we are going to mix it with sodium carbonate. So according to the double displacement rules, our products should be potassium carbonate and sodium sulfate. But the thing is that both these salts are soluble because all alkali metal salts are soluble. So in this case, we don't have any solid, liquid or gas on the product side. So in this case, our answer is no reaction. We will not have any reaction. Next, now we are mixing the same sodium carbonate, but it's not sulfate, potassium sulfate, but it is sulfuric acid. So the same anion. What's going on? We should have sodium sulfate, right? And hypothetically, we should have carbonic acid, H2CO3. But we know that carbonic acid is very unstable and it immediately decomposes and gives us liquid water and carbon dioxide gas. And this is soluble. So in this case, we have 3 products. One is liquid, one is gas, so we do have a reaction. Now let's check if it is balanced. I guess it is balanced 2 sodium, 1 sulfate, 2H2, 1 H2 I mean, 2 hydrogen atoms and 1 carbon, and 3, 1 plus 2, 3 and 3 on the left side, oxygen atoms. So this reaction is balanced. We can start to write complete ionic reaction. So this is soluble, so we are breaking it to Na plus CO3 2 minus plus 2H plus SO4 2 minus, right? And they are all aqueous. Now, sodium sulfate soluble, so it's going to be 2Na plus SO4 2 minus. And we don't break liquid water and we don't break gas, carbon dioxide. So now we can cancel ions, spectator ions which appear both on the both sides. 2Na plus, we have it on the left side and we have it on the right side. And 1 SO4 2 minus. So these are spectator ions. And what is left gives us net ionic equation. So this is complete ionic, and this is going to be net ionic equation. So it is 2H plus carbonate ion and products liquid water plus carbon dioxide gas. And this is our net ionic equation. Neutralization reaction. It is one of the subtypes of double displacement reactions. We should combine again second cation with the first anion. So first product is calcium nitrate. Calcium is +2, nitrate -1. So we should have two nitrate ions to balance charge of calcium 2+. And this is soluble, all nitrates are soluble, plus H plus and OH minus will give us water molecule liquid. Now let's balance it. So one calcium, but two nitrate ions, so we should put 2 here. And now to balance hydrogen and oxygen, we should put 2 in front of water. And now we'll get 4 hydrogen atoms on the right side. Let's check 2 plus 2, 4. And 2 oxygen atoms on the right side. Let's check 2 oxygen. So this is balanced. Can we write complete and net ionic? Yes, of course we can. So it's going to be 2H plus 2, because 2 applies to both sides, NO3 minus plus. Let's consider this soluble when it is on the reactant side, because it is slightly soluble. Plus calcium 2 plus 2 OH minus, and all are soluble, aqueous. All nitrates are soluble, so this is going to be calcium 2 plus 2 NO3 minus. And liquid, we don't break liquid. H2O liquid. So we have calcium on the both sides, we can cancel it. And we've got 2 nitrates and 2 nitrates. So calcium 2 plus and nitrate ion are our spectator ions. And what is left is our net ionic equation. But okay, let's first write it in this form. 2H plus 2OH minus. It gives us 2H2O. But when we look at it, we can see that we can reduce, we can cancel all these 2 coefficients, and our final net ionic for neutralization reaction is H plus OH minus, and this is formation of liquid water reaction. So net ionic equation for neutralization reaction always include formation of water. Now the next, also neutralization, base and acid. We know that according to the double displacement rule, we should combine barium 2 plus with sulfate 2 minus. So we already know it's going to be barium sulfate, and we know this is insoluble, solid. And the rest, OH minus and H plus, will give us water, liquid. So we have 2 products, solid and liquid, no soluble products. Let's check coefficients. So 1 barium, 1 barium, 1 sulfate, 1 sulfate, but to balance it, we need to put coefficient 2 in front of water, and now it is balanced the same way this one was balanced. Now let's try to write complete ionic. So we can break this barium 2 plus 2 OH minus plus 2H plus plus SO4 2 minus, and it is barium sulfate insoluble plus 2 water molecules liquid. So we don't have any ions on the right side. We don't have anything to cancel, meaning that our complete, in this case, our complete ionic is the same as our net ionic. So this equation is both net ionic and complete ionic.